Okay, so we're going to talk in more detail about this if-else sequence and as a programming structure in R. The basic version of it is here, ending not expression. We'll talk about what the if true means in just a moment. So what it does is it evaluates a condition. So if x is greater than 100, then some expression gets evaluated within the code. Okay, so this expression only gets evaluated if it's true. So if true is not part of the code. Okay, keep that in mind. This is just saying the expression gets evaluated if this condition is true. So you could write it in its most simple form in this first line, or you could get more complicated and use the curly brackets. So the reason behind using the curly brackets here is you can have multiple expressions. So you may have a sequence of programming statements that need to be compiled and evaluated if this condition holds. And then you can contain them all within these brackets. So everything contained within the curly brackets gets evaluated. So we can get a little bit more complicated than the original by adding an else statement. So here we still have if condition, that expression gets evaluated if true, but now we have else, another expression that gets evaluated if the condition is false. So this just gives you two different sets of operations that could be performed based upon this conditional statement. Also, just like above, we can incorporate this curly bracket so we can have multiple expressions if true and multiple expressions if false. Here's an example. Okay, so we want to say calculate the median of a random sample. We know that this is handled somewhat differently if n is even versus odd. If it's odd, then we have a nice central point. If it's even, convention is to take the mean, balanced mean of the two center points. So let's say we have a set here. Notice that this is of length, this vector is of length 6. So we're going to have an even length. We're going to sort the data because you always sort the data before finding the median, right? Then we have a condition. So if n modulus 2 is exactly 0. So what does that mean? That means it's even. Because if you can divide by 2 and have a remainder of 0, then you know you have an even number. So we're going to have this programming expression. Notice what's contained within the brackets is this that computes the sorted n minus 2 and 1 plus n over 2 and computes the mean of those. Okay, so this is assuming we have non-missing values, or else we'd end up with a missing value for median here, which would not be right. But I think we can reasonably assume here that every vector will have non-missing values. Then if it's not even, but instead odd, then we just take the value that is in the n plus 1 divided by 2 position, just as it states up here. And then we print out the median. So here's one use, simple use of the if then and else statement. Of course, there is a median function in R, so this is just for demonstration purposes only. There's a similar expression that's a little bit more succinct, and it's the if-else, and this returns a value with the same structure as what's used, except it's going to be depending on whether that element of the test is a true or a false. So here we have the test that gets placed in the first position, and then what do you do if that that test is evaluated to be true? Then you have something that gets returned, or something that gets returned in the event that that test is evaluated to be false. So this works very well. It's very nice for returning values where maybe you have a vector of values and you just want to do a quick little test on that vector to test some condition. I use them for cases like that. There's also other short cases. For a long time I used if-else statements when I really only needed to use some logical expressions, tests. And so there are some times that I've looked at old code and thought, yeah, the if-else works, but something even more rudimentary programming structure-wise works just as well. So here we have a sequence, x, a vector. We're going to evaluate if x is less than or equal to 1. So notice that'll basically give you a cutoff here. So those first three are less than 1. And if they are less than 1, then we call them small. If they're bigger than 1, we call them big. Simple enough. Here we have a matrix. And here we're running the test on each element of that matrix. So notice, if y is greater than 3 and y is less than 7, so that would include 5, 4, 6, then we're going to assign a 1. If it's anything else, like 1, 3, 2, 7, 8, then we're going to assign a 0. And that's exactly what we get down here. 4, 5, 6, those positions get a 1. Okay, another expression that is useful within R is the switch function. And what this is going to do is evaluate an expression and return different expressions depending on that value of the expression. So remember back to when we've done different things like maybe categorized numerical values, such as, I don't know, body weight or body mass index. And we might classify them as being underweight, normal weight, overweight, something like that. This switch expression is useful in cases like that. So expression needs to be a single character string or a number. It can't be a vector. So that's one limitation, although you can combine switch function with the apply function so that it can operate on array type objects like a vector. So we have a comma separating the list of the name or the number expression. If there's an exact match between your expression and your name number, then that expression is evaluated and returned. If there is no expression, then the next non-missing expression is used. We'll see this in a moment. If there is no match between expression and the name number, then the first unnamed expression is in the ... is returned. Okay, so we'll see this again in a moment. You don't need to put name in quotes inside switch, but expression is gonna need quotes. Again, let's look at an example. Some of this is hard to understand without just actually seeing it applied. So here we're going to calculate a geometric mean. Okay, this is just another way to measure central tendency of a vector. Here we are writing a function. We'll get to this later right now, but let's just look at the contents of the function, okay? And we're using this switch command as the contents of our function. So here we have our measure. So this would be some measure of central tendency. And then we have how we can define these different measures of central tendency. So there's a few things just to point out some details about how to be very careful with using a function such as switch, okay? So let's look at it. Don't worry too much if you're not familiar with the geometric mean. This is just another way to measure central tendency, as I said before, but otherwise notice we have the median function and the mean function in there. So here we generate 100, 0, 1 uniform random variables. We're going to use a central function on that y. So that is our input vector right there, y. And then our measure is going to be mean. Okay, so what we see here, the 0.510, that's right near the center of what we would expect the mean to be for 0, 1 uniform variables, right? And that's what we get returned. Notice that we used lowercase mean here, and lowercase mean matches the mean function, okay? So if we put in uppercase mean, then the next non-missing expression is going to be used. So notice uppercase mean is placed right here as our first ... value. And because it has no assigned function or output to it, or set of expressions to it, we're going to go to the next one, which also happens to be the mean. Okay, but if we make a mistake like using uppercase median, because notice the median is inputted as a lowercase value, character string, but if we put in an uppercase in here, it's just going to tell us that's an invalid measure. So you could fix things like this by just making everything uppercase or something. That's what I would do if I were writing this as a real function, not as a demonstration. But we would get an invalid measure because nothing matches exactly median. Okay, so finally we get geometric, and we get the calculation for the geometric mean because that is inputted correctly. Oh, and just notice too that all of those, that measure is put in for the switch function, and all of the options for that measure follow it. Okay, so if you're going to have a measure put in using that switch function, make sure that directly following it, that ... is just all of the possible things you would want to result in, including an error if you want that to show. Okay, so finally we get to for loops. This is a really important programming structure within R, but it's also one to really think about using before you just automatically use it. So this is familiar to you if you've used any other programming languages. This is for some variable, index variable within a sequence. So variable is just going to be that index or looping variable that you're going to use, and it's going to go through a sequence of number. It may be 1 to n, like we see down here, or it may be a character, a vector of character values that it could go through. It could be a lot of different things. Then while we index through that list of that sequence, we implement a set of expressions. Okay, so for example, we're going to calculate 10 factorial using a for loop. This would not be the way to calculate 10 factorial, by the way. There's a much better way to do it, but it will demonstrate the for loop to us. So here we initialize f to be 1. Then we set up our for loop. We want to calculate 10 factorial, so we need to index I from 1 up to 10. And we're just going to replace f with the product of f, the current value of f times I. So at first, f will be 1, and I will be 1. So we have 1 times 1, and we get back 1. Then we output that value. So cat, remember, this is a function within R that just will print out a character string. So it's going to print out the value for I, the value for S, and then this symbol just skips to the next line. So this way we're going to get 1, 1. Then in the next iteration, when f remains 1, but I becomes 2, we'll get f updated as 2 and I updated as 2. So then we'll print out 2, 2, then next line. Then I gets updated to 3. And then f, remember, is 2, so we get 2 times 3. So f becomes 6, so we get 3, 6, and so on. So go ahead and type this in. Make sure that you can run this, and that when you run the function call factorial, that you get the same value. Okay, notice this is just going to print out f here. Factorial is a coded function within R, I should point out, that will compute the factorial of any number. We also have while loop structures within R, so this is going to be evaluating a condition and then performing that condition over the time where that condition still holds true. So these can be a little problematic because it's easy to create an infinite loop. So make sure that you have some sort of indicator variable and you change its value within each iteration, or else you're going to run into that infinite loop problem, which is no fun. So initialize, for an example, we're going to calculate 10 factorial again, initialize I to 10, f to 1. While I is bigger than 1, keep doing these computations. But notice we change the value of I within the loop each time, so we're going to successively decrease n by a unit of 1 each time, so that we will end up at the last loop, I is equal to 1, and then we evaluate that condition and we say, no, if I is equal to 1, it's not bigger than 1, so we're going to quit our while loop and print out the value of f. We could also use, similarly, a repeat loop within R. For a repeat loop, you really just need to make sure you put an if expression in there where you break the loop, or else, again, you're going to have an infinite loop without this if statement. So you just have your expressions in there, and it just repeats everything indefinitely until a condition is met in which you break the loop. So this is the only way to get out of that loop. So if we're going to do 10 factorial again using this, we can initialize I and f. We're going to do the same calculations as we did in the while loop. But now we're going to have, instead of having our condition up here for the while loop, we're going to have if I is less than 1, then we break. Well, I just showed you the for loop, the while loop, and the repeat loop. Now I'm going to tell you, try to avoid loops. It's